video is going to go over rational exponents. So before we start with rational exponents, well, first of all, let's review what rational means. Rational means a number that can be changed into a fraction. So yes, we have not had any in our problem so far, but we have not had exponents yet that were written in rational form, fraction form. So before we even try to do that, let's review and make sure that we understand just how to do regular exponents that aren't fractions. So if we have 4 to the third power, remember when the exponent is positive, it means to multiply the base that many times. So 4 to the third power is 64, because 4 times 4 is 16, and 16 times 4 is 64. Okay, then we have 4 to the 0 power. So a couple chapters ago, we learned about exponents that were 0, and anything to the 0 power is always 1. And remember why that is. If we had 4 squared over 4 squared, we'd have 16 over 16. And 16 over 16 is 1. So what happens is the 4 and the 4 here divide out, and then these 4 divide out. There's no 4s left. They divide into each other, and it represents 1. So when you have an exponent of a 0, it means that the 4s all are gone. So 0. There's 0 4s. They all went into each other, and it makes 1. If we use our rule, which when we divide, we subtract the exponents. 2 minus 2 is 0. It represents they're all gone. So whenever you have a 0 exponent, so if you take your calculator and you take any number like 99 and you raise it to the 0 power, it's always 1. And this is why. Okay, then a couple chapters ago in chapter 6, we learned about negative exponents. So you would ignore the negative and you would do 4 times 4 times 4, just like normal. But when it has a negative exponent, it means that that answer is in the denominator. So 64 is in the denominator. And since there's nothing on the top, we're going to go ahead and put a 1. So again, when something has a negative exponent, you compute it just like normal, as if it was 4 cubed, and then it moves to the denominator. Now, if the negative's in the denominator, you move it up. So negative exponents move that value. So in this section, we will learn about rational exponents, or that we could also call that fractional exponents. And when you see an exponent that's a fraction, it just represents a radical. So rational exponents are just another way to write a radical. So think of it this way. When we have fractions, right? If I have 4/8, that's in fraction form. But I could also simplify it into 1/2, so radicals can be simplified. And then fractions, if you divide them, 1 divided by 2, you can write it as a fraction. So we have a fraction form, a decimal form. We can write numbers as percents. If you have 4 out of 8, you have half, right? 50%. So we have different forms that a number can be written. Well, the same thing with exponents that are fractions. So if we had 4 to the 1/2, that's just another way of writing this. So we would have the denominator would be the index. So this number would be the index. And then this would go in the inside here. Or it could be done after, like this. So the denominator is the index, and the 1 can go inside with the 4 or be done after the square root. So again, if you see an exponent that's a fraction, it just means it's a radical. Change it to a radical. So if we have 4 to the 1/2, again, that just represents the square root of 4. because the denominator is the index and the 1 would go inside, which anything to the first power is itself. So it's just the square root of 4, which is 2. Now let's check that with our calculator. So if we put in our calculator 4 raised, I need parentheses because it's a fraction, so 1/2. 4 raised to the 1/2 power is 2. So a fraction exponent doesn't tell you how many times to multiply the number. It's just another way, just like a decimal, right? A little dot, decimal answer versus a fraction answer. So it's just another way to say the square root of 4. So maybe you don't have the square root button on your calculator on like maybe certain calculators, but you have a fraction bar and an exponent key. You can enter the square root of 4 as 4 to the 1/2. So if I had 9 to the 1/2, it just represents the square root of 9 because the denominator would be the index here and you'd have a 1 in there. So it's just the square root of 9, which is 3. If we had 16 to the 1/2, again, that just represents the square root because this would be 2, the denominator, and the square root of 16 is 4. Okay, if we had 8 to the 1/3, so 8 to the 1/3, all that represents is a radical. The denominator goes here, and the 8 to the first power can go here or after it. So this is saying what times itself 3 times is 8. So the cube root of 8 is 2. If we had 27 to the 1/3, that represents the denominator is 3, so the index is 3. And it's saying what times itself 3 times is 27. So 3. Okay, so notice I put this, this is a movie, a kid's movie, Inside Out. So that just helps me remember if this is the numerator and this is the denominator, that the denominator is the one on the outside right here, the little index number. So this just helps me remember that the top number, the numerator, can go in, and then the bottom one will go outside here. Okay, so let's go ahead and write that down. Okay. Let's go ahead and put the index of the fractional exponent, the denominator. So the denominator of the fraction becomes the index of the radical. So the denominator, the bottom of the fraction, is going to be the index of your radical. And then your numerator, so the top, the numerator of the fraction, the top of the fraction is going to becomes the exponent. And it could go inside the radical or outside. So the top exponent is the exponent. It could be the exponent with the 16 in the inside or the exponent on the outside of the whole thing. So the numerator is the exponent, the denominator is the index. Now let's just practice this. So if we have 32 to the 3/5, your brain should now say, oh, radical. Whenever you see a fraction as an exponent, you put one of these symbols. The denominator goes here, so the 5 goes here, and then the 3 can go here, or the 3 could go here. Now, it doesn't matter where the 3 goes, here or here. Now, there's advantages. So the better way is to put the 3 after in some cases. For example, here. This is saying what times itself? 5 times is 32. So I know that 2 times 2 times 2 times 2 times 2, that would make 32. So that would be 2. And then 2 cubed, that would be 8. So for me, it was easier to compute if the 3 was here. So I liked this way. Now, if you put the 3 in the inside, then you have to do 32 times 32 times 32. Ooh, I wouldn't want to have to do that. I'm going to cheat real quick. Let's see what 32 to the 3rd power is. Wow. So this would equal the 5th root of some huge number. So if you do the exponent in the inside, it makes a giant number in some cases. And then you'd have to, if you didn't have a calculator, think about what number times itself 5 times makes 32,168. So that is why I'm not going to do it that way, because that makes a huge number. Whereas this keeps the number here small, and then I would take care of the cube. So when would I put the exponent in the inside? Well, in the problem up here, it was 1/3, and putting the 1 in here didn't really affect things because 8 to the first power was just 8. So the cube root of 8, no problem putting the 1 in the inside. But it does work both ways. Okay, so let's go ahead and try 81 to the 1/2. So when you see a fraction bar as a exponent, you immediately put the symbol. The denominator is the index, and then the 81 goes inside, and then the 1 can go here or around it. Now it doesn't matter which one. In this case, this one's fine because anything to the first power, I'm okay doing this because 81 to the first power is just 81. And then we know when the index is 2, we don't have to put the 2 there. This is optional. When it's a 2, we don't need to write it. So it's just what is the square root of 81, which is 9. And then again, you have calculators, so you can check it and see, does 81 raised, we need parentheses because it's a fraction, to the 1/2 power. Let's check if it's 9, and it is. All right, let's go ahead and check, or go ahead and do -8, the quantity -8 to the 1/3. So again, whenever you see a fraction as an exponent, you immediately put one of these symbols. The denominator is the index, and then because there's parentheses, I want to leave the parentheses there because they are there probably for some reason. And then the 1 can go here, or the 1 can go here. In this problem, since the exponent is just a 1, it really doesn't matter. So I'm going to go ahead and put it here. So -8 to the first power is just -8. And then what times itself 3 times is -8? That would be -2. Since -2 times -2 times -2 is -8. All right, so next one we have the quantity -64. So we see that fraction, so we know we need a radical. The denominator is the index, and then we'd have parentheses because there's parentheses, and we'd either put the 4 here or we'd put the 4 after. Okay, now if it was me, I would do it after because I wouldn't want to have to do the cube root of this huge number. So I would rather put the 4 after, and I'm going to start with this. So this says, what times itself 3 times is -64? So that would be -4 times -4 times -4. Okay, and then it's in parentheses, and the exponent is around it. So now it's saying, what is -4 to the 4th power? So -4 times -4 times -4 times -4 would be positive 256. So that would be our answer. Okay, let's go ahead and try number 5. So we see a fraction as an exponent, we immediately put one of these symbols. There's -144 in parentheses, so